Hello, this video is intended for students in my CS 222 class at Ball State University. It may be helpful for others as well. This demonstration will start with nothing in IntelliJ IDEA and a Java Gradle project. A single test is created along with the supporting class and a method in the production source folder. Finally, a local repository is created and code is committed to it. Ultimately, a remote repository is created and the committed code is pushed to the remote repository. Let's get started. I've just opened IntelliJ IDEA and I'm going to choose New Project. Depending on the version of IntelliJ you have, your screen may look a little different, but we're looking for the fundamental things. We're going to give it a name for this project, and for this project I'm going to choose Leap Year. We want to make sure it's Java, and we want Gradle. If you don't have a JDK chosen, then select one that you have access to, and then choose Create. That opened off screen, so I'm going to bring it back. You'll notice down here in the bottom, there's a little progress bar where it says Gradle Building. That will take a little while depending on the speed of your machine. It also takes a little bit longer the first time you create a Gradle project within IntelliJ. While we're waiting for that to complete, this build.gradle file is nothing we're going to worry about right now, so I'm going to go ahead and close that. We'll talk more about it in the future. Also look here at the project structure. Notice there is a .idea folder, a .getignore, and here in just a bit there will be additional folders that get added into that as the Gradle process finishes creating the project structure. And there we have source, and inside of that we have a main and a test folder. Inside each of those we have a Java folder and a resources folder. So Gradle has a specific structure of folders that it is expecting. Don't change the names, don't move them around. That will break what Gradle is going to do. We're not going to extensively talk about Gradle today, but just know that it is a tool that will manage dependencies for us. Again, we'll talk more about that in the future. So we've got the basics of a project started. We're now ready to add some content to it. As I go through the example today, I will do my best to mention whether what I'm doing is something you would do once per project or once per installation of IntelliJ. This first thing I'm going to show is something that we'll do once per installation of IntelliJ, and that is we need to tell IntelliJ what version or what type of version control we're going to use. So to configure IntelliJ, I'm going to go to the main menu, choose File, choose Settings, and on the settings, if version control did not open automatically, expand that, go down to GitHub and choose that. And in my instance, I've already configured GitHub for use within IntelliJ, but if you had not done that previously, you would need to add your user access to GitHub in here, probably by clicking on the plus, depending on the version of IntelliJ you're using. But the bottom line is you need to make sure that you have yourself configured and IntelliJ is able to make that connection. Once you know it's working, click OK. This next step is something we'll do once per project. We're going to choose the main menu again, come over to VCS, and choose Enable Version Control Integration. If you're ever in a situation where you're not sure if you've done this or not, simply go to the VCS part of the toolbar. If it says Enable Version Control, you have not done it yet. Because once we choose this, that option is removed. So I'm choosing it. will pop up here. We want to choose Git, and then we're going to click OK. This will do a couple things. One, telling IntelliJ what version control we're wanting to use. Also notice down here in the corner it says that it's created a Git repository and tells us where that's stored at. Again, we'll talk more about it in class, but the version control process is that as we write code, we can create snapshots locally on our computer, and then later we can take those snapshots and push them to a remote server, in our case GitHub. So this is just creating that local storage area for us to commit our code to locally. If when you are telling it that you're wanting to use Git as your version control, if it complains about not having Git, you then would need to go to git-scm.com and download and install the Git program, making note of where git.exe is, because you'll need to tell it that if it's not able to find it. So the next step is, if we're going to have Git track the code that we're making changes to, we need to tell it what files within our project we want it to track. It usually is not the case where you want to track every single file within your project. There's some files in the project that are simply there because of IntelliJ and configuration of IntelliJ. Those typically are not files that we want to track. So I'm going to come over here. I'm going to collapse the source folder just so we have less to look at. Notice there's a .gradle folder and also a Gradle folder. We do want the Gradle, but we do not want the .gradle. So I've selected Gradle. I'm going to press Control on my keyboard so I can select multiple folders. We want source, we want build.gradle, GradleW, GradleW.bat, and settings. So it's most of the files and folders, but not all of them. Once I've done that, I'm going to right-click on the selected file area, come down to Git, and choose Add. And what that's telling it to do is add those files to the list of files and folders that it's tracking. Down on the bottom right, it's saying adding files to VCS, VCS being version control system. As we go forward and create new files, it will ask us if we want to add that to the file list that it is tracking. And generally the answer is going to be yes, we want it to. So now we've got things set up, we're ready to start creating some code. Because we're doing test-driven development, we're going to start by creating a test rather than production code. I'm going to come back over here, open up my source folder, open up both of the main and test folders. Before we actually create our first code file, we need to create a package in each of them. So I'm going to right-click on Java folder, New, Package, and let's call the package edu.bsu.cs. I'm going to press enter, and I'm going to create the same package in the test Java folder. Okay, so now I have packages in both areas. Now I'm truly ready to start creating some code. And again, we're going to start in the test area. I'm going to right-click on my package, choose New, Java class. It wants a name, so I'm going to call it Leap Year Calculator Test. And let's not capitalize the E. The reason I'm calling it that is Leap Year Calculator is ultimately the name of the class I'm going to create in the production area, and I'm creating a series of tests to test that class. So I'll be creating a series of tests to validate that class. Once I've got the name, I'm going to press enter, and it has created a new Java file within the package. It's now asking me if I want to add that file to Git. I'm going to ultimately say add, but notice there is a checkbox here if you don't want to make that decision every time you're creating a file. You may choose to do that. I leave it unmarked so I can demonstrate it in this particular instance. But most of the time you will want to add. So let's start adding some code. I'm going to come inside of the curly braces and type @test with a capital T. You'll notice it's prompting me asking if I want to add in some dependencies with import statement. And so I'm just going to press enter on the first one. Yes, I want to import JUnit. And so that's added the import automatically. We now have the @test in yellow. It's an annotation. Pressing enter. So we proceed. Public void. And I'm going to call this test 2024 is leap year. The reason I'm calling it that is I'm using a descriptive name describing what this test is going to test for. I'm going to test for the year 2024, and I know that 2024 is in fact a leap year, so I'm declaring what I expect. Add in, and so then I need to create an instantiation of my class that I have not yet created, but that's fine. We're describing what we want to happen. So let's call this leap year calculator. And we'll call our instance leap year. Notice there's things in red telling us there's a problem. That's fine. We'll come back and fix those later. The test is going to be very short. Let's just get that entered in, and then we'll let IntelliJ help us finish things up. Boolean result. And here I'm going to call my leap year and call a method that I've not yet created, but that's fine. Is leap year. And I'm going to give it an argument of 2024. And then I'm going to use an assertion, or as an assert true of the assertions. And I want to assert that the result I get back is in fact true, because I'm expecting 2024 to be a leap year. So that's the test we've created for instantiating the leap year calculator. We're using the method within that object to test the 2024 year. We get a result back, and we're saying that result should be true. But we can't run this because IntelliJ knows that there's some things that don't exist. So let's click on leap year calculator. I could go over and create a Java class myself and manually enter code, but I'm lazy like many people. I'm going to let IntelliJ do some work for me. So as I click on that, it hovers over and suggests or asks if I wanted to create the leap year calculator. I can click on that, or if it doesn't pop up and do that, you can also have your mouse insertion point over the word and press Alt-Enter on the keyboard, and that'll pop up a list as well. So I'm choosing Create Class Leap Year Calculator. It is confirming that I want it created in that package, and then here we need to make sure it creates this in the production area, that is the main rather than the test. And notice it's saying test, so I'm going to hit the drop down, choose main, and then choose OK. It over here, if I open up the package, we'll find that it has created the class file there. It's asking me if I want to add that. Yes, I do. And it's adding it to the Git tracking. And it's opened another tab here showing me the class it's created. Again, I could go ahead and start typing the rest of the method here, but being lazy, I'm going to come back over here to my test. I'm going to click on is leap year, and so there I'm going to press Alt-Enter. An option is to create the method is leap year in the leap year calculator. That's exactly what I want to do. I choose it, and it's dropped that code now into the leap year calculator production code. If I come back to test, we'll notice we still have one thing that's highlighted in red that's an error. So again, mouse over it, I can press Alt-Enter, or I can choose the import class. And that adds the import statement. So in our test, no red left, things are happy. Over here in the leap year calculator, nothing's shown in red, but if we look in this top corner, we'll notice we do have one error and one warning. The error is because we have told it we're going to return a Boolean value, but we have nothing inside of the method. So let's click here, and let's simply return false. Probably help if we spell return correctly. Now remember, as we're doing test-driven development, we want our first run of our test to fail. We want it to be red. Then we'll make the minimum change to make it succeed and hopefully get green as a success. And then we come back and look at refactoring. So we're shooting for that first red step, the failure step. So let's run our tests. I'm going to come over here to the test folder, right-click on it, come down to Run Tests in Leap Year. I chose that. It's starting up. It'll take just a moment to get things going. And here in a moment, it has told us test failed 1 out of 1 test. We've created 1 test, and it has in fact failed. And just providing a little more information, it expected true because that's what we told it to expect. It received false because that's what it's going to return every time right now. So it did what we expected. So as we think about this now, we've got the red step. Let's try to get to green in as few steps as we can, as quick as we can. Well, the simplest way to make that test succeed is instead of returning false, we're going to return true. And again, we can come over here and run our test, or because we've run it once, we can come up here to the top and choose the run here. Again, starting the test up, and this time we have a green check mark. We have 1 test passing out of 1. So we had red, we had green, and now we're at the point where we need to look at refactoring. And we'll notice that we still have one warning over here. And that warning is that I is never used. Well, that's reasonable. We haven't fully implemented our code yet, and so I isn't actually going to be used. But I isn't very descriptive of what it is. Let's change that to year. That's not going to make the warning go away, but it will provide a more descriptive name for that parameter as we use it in the future. So again, we made changes to the code. Let's run the test and make sure we didn't accidentally break anything. Pretty hard to do with just that minor change, but sure enough, our tests still pass. So at this point, I'm going to show an example of how we would take a snapshot of what we've been working on and save it or commit it to our local copy of the repository. This is minimal work. You might actually do a little more work before you make the first commit, but there's no absolute rule about how often or how quickly you should do commits. One way of thinking about it is don't go any longer than you have to, because if something does happen and you lose code, you're going to have to rework that code. So committing often so that you don't have large chunks of code to recreate if you need to is a positive. So to commit this to our local repository, I'm going to right-click on our project folder, come down to Git, and choose Commit Directory. Depending on your version of IntelliJ, you may also have the VCS up here where you can hit the drop down and choose Commit Either way, you're going to end up in the same place. It's showing the files it's going to record into the local repository, the snapshot it's going to take, and then there's an area down here where it wants to know what you did. And this is where you would type a short commit message briefly describing the changes you've made, and it should start normally with a present tense verb. So you're not saying what you did do, you're saying what will happen if this code is implemented. In the case of the very first commit, the convention is to just simply use the phrase initial commit. So I've added that. I'm going to choose commit. Notice it's doing some checking. It's also giving us a progress bar. And if it finds some problems, it may report that to us. And usually you would not want to commit code that has problems within it. You only want to commit good code. If there were errors, in this case it does come up and say we had a couple warnings. So let's review the code and see what it's complaining about. In this case, it's saying that year is never used, and we have an unused import statement. So we know year is not used because we've not fully implemented this code. So that one's kind of okay. In terms of having an unused import statement, it looks like this security public key. I think that came in when I started to type public here and chose the wrong thing, and it automatically imported that. There's no reason for that to be there, so let's remove that. So we've made that change. I'm going to come back over and do the commit again. It doesn't have anything marked to commit. We do have one changed file here, so I'm going to indicate that's what we want to add to the commit. We will append to the initial commit. Normally you would not append, but in this instance we're wanting to treat this all as one thing. Normally you would have each commit its own separate thing. And I'm going to amend that initial commit. It's doing the checking, and we should just have the one warning this time. Okay, one file committed, initial commit. Still checking. And yes, there's our one warning. And we could review, but we know what the warning is, so I won't take the time to do so this time. At this point, in a normal situation, you would move on to your next test or the next piece of code you're working on, make further changes, stopping every now and then to commit to your local repository. Ultimately, you're going to have a set of commits you've done. You've been working for an hour or a few hours and collected a bunch of commits, and you're ready to push that out to the remote repository so that you've got a second backup of it, if you will. But also, as you're working in teams, that pushing it out to the remote repository will make that code accessible to the other members of your team, whereas when you have it on just your local machine, it's not accessible to anyone else. So let's pretend we've continued working and we're now to the point where we're ready to push it out to the remote repository. Let's see what's involved there. So before we can push it to the remote repository, we have to have a remote repository to push it to. So let me open up my browser here. I've already logged into GitHub, and for purposes of our course, you want to make sure you're within our course organization. So having just logged in here, it's in my area. I'm going to click up here in the top left and choose our organization, and then view organization. And because it's completely empty organization right now, we just have this create new repository button in the middle. But as there are others out there, there will be a new button up towards the top you would click on to create a new repository. So we'll do that. We need to give it a name. So I'm going to call this initial class demo. It validates the name's available. Obviously, if it's not, you'd have to give it a different name. You can give it a description if you wish. For our purposes, private is what we're looking for. Do not check the add readme, and the other items are, the default answers are fine for us at this point. So I'm going to choose create repository. It will take it just a moment. It has basically created a big empty box in GitHub on the web. What we're going to do here at this point is copy this URL. I can drag across it and copy, or there's a convenient copy button here at the end. Now I'm going to go back to IntelliJ, and we need to now tell IntelliJ that we want to push all of our commits that we've done that committed them into the local repository. We want to push those to our remote repository. To do that, I'm going to close out this commit area and open back up the project structure by clicking on the folder button. I can choose to right-click on leap year and come down to Git and choose push, or again, depending on the version of IntelliJ you have, you can choose master here at the top and then push. The very first time you're pushing to a remote repository, you have to tell IntelliJ where that repository is located. And that's why we have define remote here. And so we're going to choose that. I'm going to paste in the link that I copied from GitHub and click OK. This is something you just have to do once for a project. Once you've told it where to put it, it will know where to put it. It's taking just a moment to see if it can make that connection over the internet to gain access to that. It's, in fact, was able to. It's now says master instead of define. It's here on the right-hand side listing all of the files that we have changed and committed locally. It's got the wording push anyway because it is aware that there is one warning. Again, normally you would not push code, commit or push code that has warnings or errors. In this case, for purposes of illustration, we're going to go ahead and do that. So I push, again, progress bar down here at the bottom. How long it will take is a function of how much code it's transmitting, the speed at which it's able to transmit, how busy your network is, etc. Okay, pushed master to new branch, and at this point, if we go back to our browser and refresh this page, we will find that there is the folder structure that exists on our system that has now been copied over to GitHub on the web. We can open up the source folder, and we find that we have both main and test folders. Inside that we have Java. Inside that we have the package that was edu, bsu, cs. Each of those turn into a folder in your file system, but GitHub and IntelliJ realize that that's really all just one thing, and so it treats it as one thing. If we click here, we can see our Java file inside of it. There's our Java code, and if we back up and choose test instead, here is our test code. So our code now exists both on the web in GitHub. It also exists locally on our machine. And again, if others have access to your repository, they could pull that code from GitHub and have access to the same code that you've just pushed out there. And that basically is what we're going to illustrate as the next and final step of how can you pull code from GitHub onto your local machine. So to show that, let's go back to IntelliJ. I'm going to close out this project. I'm not going to close IntelliJ, but I'm going to close the project. So we're here in IntelliJ as if we had just started it. We just closed the project, so that's what it's looking like. Here's the new project button we use to start this whole process. We're not wanting to create a new project. We're wanting to get code from VCS, Version Control System. So I'm going to choose that button. and then it needs to know where to get it from. We also have a choice of version control systems, which we're leaving that at get because that's what we're using. I'm going to temporarily come back over here to GitHub, and we need to make sure we've got the URL to this repository. So I'm in the initial class demo repository. I'm choosing code over here, and again I could highlight that and copy it, or I can choose the copy button. Let's minimize that, come back to IntelliJ, paste that URL in, confirm where I want to place it. In my case, for demonstrations, I'm just placing it on my desktop so I can find it later, but you would want to put it in your true location of where you want to store your code, and then choose clone. So you're making a copy, you're cloning the code from GitHub. It takes a moment to make that connection and copy the code. Again, how long it takes is a function of how much code and your connection speed, how busy the network is. But normally, again, it goes fairly quickly. Okay, that is completed, and open the project. Again, if we open up and expand out the source and the main folders, it looks kind of funny, but notice Gradle is still running. It's still sorting through all of this code and file structure. So let's give it a moment. And what you'll find is once it's finished the build process, it'll collapse these folders because it recognizes what they are as packages. Okay, the build process is finished. If I expand out our project, we have the source folder, we have the main Java package code file, and the same for the test. And that is then just exactly the same thing we started with. We've committed a series of things locally to our local repository. We ultimately pushed that to our remote repository. I closed out our local project that we'd called Leap Year. I had pushed it out to the remote repository. We brought that back as something called initial class demo, and we are looking at that code now again. So hopefully that's helpful. There will be a transcript available for the individual steps to go through as well, and you're always welcome to ask me questions if you have them. We'll see you in class.